Okay, our next expert is Mr. José Ignacio Latorre from CIV. He will be presenting the topic electric vehicle charging stations, use cases and applicable regulations. Mr. José Ignacio Latorre is the Business Development Manager of e-mobility in CIV, expert in international development of the industrial company. He is in charge of the strategic definition and worldwide launch of the EV charging infrastructure business unit. CIV is a leading manufacturer of a smart solution for the grid, with knowledge in 4 key areas: protection, control, communication, and metering, offering complete solutions for the challenges of the current electrical system. Mr. José Ignacio, you have the floor. Thank you.
Thank you very much. Let's see if I have more chance than Javier. Okay, screen 2. Okay. So, please let me know if you can see my screen.
Yeah, it's working. Thank you.
It is working. Okay. Well, first of all, thank you very much for the chance to participate in the event. Thank you very much to CM. Also, thank you very much for all the European attendees who are at present probably at dinner time, and also to the South American attendees that might be missing his lunchtime. A quick introduction about our company. CIV is a technological company founded in 1993. As I mentioned, we have knowledge in 4 key areas: in protections, control, communications, and metering. We are present in different parts of the world. We have more than 25 years of innovation. We are in the different organizations in our industry, advancing in the different standards of the industry, and having, we could say, as actions, 2 main actions: the smart metering and the transport and distribution network automation. Also, we are present in the EV charge market since more than 10 years. And here we are integrating, we could say that we are capitalizing the know-how we have in different areas: in the metering area, in smart grid metering, in the telecommunication technology also. So, what to say about the EV chargers and the MID regulation? The main point is that at present we don't have an MID regulation for the EV chargers, and this is creating this lack of regulation is not helping to develop industrial, we could say, industrial solutions. From the main use cases. We have different type of charging scenarios. We have AC charge and DC charge. AC charge is mainly used in domestic use cases when you are at home. You have enough time to charge your EV car. And okay, that's the best solution is an AC charge. In semi-public use cases, for example, in fleets, in hotels, when you leave your car in your company, is also the best solution. What we see is that for the public city, it's already moving through a little bit too fast chargers, to DC charge, but still we see that the AC charge will be present. And of course, for the public stations, for the petrol stations that will be in the future, the electric stations, obviously this will be always fast and ultra fast charge. So here we see that first everything that all type of a scenario where we have an invoicing of the transaction. Obviously, you need an MID meter or an MID certified product. So we could say, okay, what about residential use cases? Maybe as we have already a meter, maybe we don't need. So if we look at the residential use cases, if we have a look at the ITC norm in Spain, but in other countries is similar, in Europe, this norm in Spain shows 4 different ways to install your EV charger. You can use a collective scheme, so you have 1 meter at the origin of the installation, and then the different EV chargers will be connected after this meter. So you are not using the meter of your house. So if you want to know which is the consumption of each EV charger, obviously you need a meter for each EV charger. You have a second scheme, which is using the meter of your house, and here it is an option. It is optional, the possibility to include a meter or not. You have also another individual scheme with a meter for each EV charger, and you have the case for individual homes. So you see, we have different cases, and clearly in the scheme 1 and in the scheme 3, it is mandatory, we could say it is mandatory to have an MID meter, a meter in the EV charger. In the other ones, depends on the type of installation, might be not needed. That's clear. So how is the situation? We could say that in the EV charger market, we have 2 forces. One force will be the trend to say, okay, we need to make a mass deployment of EV chargers. So please leave it simple. We need to make to incentivize the people to use the EV car. So we need to make as simple as possible. And the MID meter is a complexity to the product, has a cost. Blah. So this has led to a lack of MID regulation for EV chargers. So it's one of the few products, I would say, that so far is not within the MID regulation. But the reality is that for the actual and future transactions, we have a need to have an MID meter. And the solution at present, it is to have a product which has been certified as a meter that you will include inside the charger, which we think that is not the right situation. So there are many use cases where we will need a meter, not residential, but in the parking areas, in public and semi-public, when you have schemes where you are going to have car sharing, which is going to become very popular in the future. Also in the situations where you have multiple prosumers, we could say, in your house with solar panels, with EV chargers, then the meter of your house will not be able to understand who is the one which is importing or exporting to the network. So our view is that it will be a mass deployment of EV chargers in the future, and it will be requested an expensive solution because the price will be important. Of course, it is not the same when we are talking about a large DC charger, that it is not important the price of a meter compared with the complete solution that will cost tens of thousands of euros. But when you are talking about a residential charger, the pictures change a lot. So we believe that the MID will be a basic request for residential chargers also in the future. also for the smart network management, including also the consumption of the chargers, this will request a lot of information, a lot of metering information. So dummy chargers will not be the proper solution for this market. So we have decided to develop an EV charger, combining the smart metering technology inside the charger. So the product, we could say, that is a mix, or is both a smart meter and an EV charger. And we will certify this product during the present year as an MID meter, with the aim to have an expensive solution for the mass deployment, which is expected for this market. And this is a real challenge, because as we don't have a norm, we don't have a real norm, MID norm, taking into consideration the particularities of an EV charger, we will have to certify our product both as an EV charger and then as an MID meter, with the complexity of making this. So this is the challenge. This is the, we could say, the situation, the previous situation. And now I will give you a short view of the product we are going to launch. No? First, I mean, we are in, as I mentioned before, we are in the market for more than 10 years. And we produce, basically, we are in the market of the AC charge. We are not in the market of the fast chargers. For the public and semi-public use cases, we have a product family called PRB, which is present since many years. And for the residential use cases, we are now, it's now under development, a new product which is called CyberSpot, which will be both targeting the residential use cases and also in some cases the semi-public applications. So this product, what we are targeting is a secure and easy to use product, having 5 key advantages. It will have easy to install, it will be easy to use, it will be secure, efficient, and also elegant and robust. I mean, the idea is that you buy once your charger, and probably you will change many times your car, but not your charger. Will be very easy to use. This is the idea. We will have a display. You can use either via the display. You will have indications, LED indications, and you will be also able to use it with an app. And to make the most common operation, to authentify as a user, to start the stop. If you are going to holidays, you will be able to log in very easily. To program your recharge schedule, to take chance of the low prices at night, to have the records, and to set up the maximum power you want to charge, or if you want to balance dynamically with the total power of your house. We have also think not only in the end customer, but also in the technician who is going to install this product, and the company who is going to give service, after-sales service on the installation. So the product is presented in this way. So you have first, you will withdraw the investment to have access to a terminal, a cable cover, terminal cover, and then you will have access to the terminals. That means that you don't need to have access to the electronics to install your product. The installation is very clean, without the possibility to damage an electronic component. It will be also, a technician could be able to make a sealing of the installation in case he's going to give a warranty afterwards. And well, I mean, also it will be secure both also in the use and in the installation. And we are including a DC leak detector device. We have the mentioned sealing screw, but also we have an opening sensor in order to check if somebody has opened the product, no? And the access to the charge will be protected either, I mean, you will have to authentify either via RFID card or either via the app. So you can go and nobody will be able to charge with your charger. And as we are having a meter, which in the future will have the MID certification, you will be able to have all the detailed information of the charge and also to program the charge function, to have a load balance with the installation and so on. So it's a product which at the same time is robust and elegant, with a lot of functionality, and which in the future will have the possibility to scale. The product will be proposed in different ways for a domestic use or for a corporate use, in 1 or 3 phase versions, in 1 or 2 plugs, with the Bluetooth or not, with the modem or not, with the Wi-Fi or not also. And we'll give a lot of flexibility to the different use cases that we can find in this market. Okay, so that's the presentation. I think I have gained some minutes compared with my colleagues.
Thank you very much. Sorry, Javier. I think Javier Díaz is ready for his presentation. So, hi, Javier. Okay, so I'm going to give you the floor, okay?
Okay, thanks again, David. I'm very sorry for this problem. I think, let me see now, it works.
Okay. Now it's working. We can see your main screen.
Okay, now it's working?
Yeah, perfect.
Okay, thank you. So I'm not going to start from the early beginning because I will just show you what screen are you seeing? The main one or the second one?
We see a car, in the main screen there is a car, and then you have some notes on your right side.
Okay, I will change the view then. Now you want to see
perfect.
Okay, thank you. Thank you again. I will just go again to the line of the presentation, and I'm going to talk about this, and we'll go to the first presentation, that is to show a synoptic view of how the energy flows from the beginning to the use in the mobility. In the top case is the conventional car or mobility. The energy comes from fuel, fossil fuel. The first difference in this way is that this energy can be stolen in a tank before selling to the consumer. In the case of the electrical energy, there are many sources of energy. There is the wind energy, solar energy, thermal energy, hydraulic energy, nuclear energy. Not all of them are green energies, but a few of them. The second difference is that the price of the energy is not changed with the time of the day, and in the case of electrical energy, it is changing from the time of the day. This energy in the top case is stored in the tank of the vehicle. In the case of the electrical vehicle, the energy is stored in the batteries. From this energy, by combustion or by electrical engine, the energy is converted in mechanical power that it is used for the mobility for displacement. The important point that is common in the two cases is that there is energy that goes inside and is produced some energy in the movement, or there are some losses in this one. If we look at the drawbacks of the electromobility, I have made it summary. The first point is the cost of the vehicle. The electrical vehicle is more expensive than the conventional car, but I think this difference is coming down, and in a few years there will be very similar. A very important point is the charging. There are two important drawbacks in the charging of the electrical vehicle. The first one is the charging points. There are not a good infrastructure or charging points. And the reason of this is that there are not enough electrical vehicles for make a profit from the charging points. And on the other side, there are not more electrical vehicles because there are not enough charging points. Another matter is the charging power that is directly related with the time that you need to charge the vehicle. That has to be reduced in reasonable times to be similar, like the refueling with the gasoline conventional car. Another important drawbacks is the batteries. The batteries is not only for the electromobility, so for all the application of storing energy. The batteries has a limited life. There are a limited number of cycles that can be used before reach the life of the batteries, and also the energy density. In relation with the performance, I think they are very similar. Maybe it's, in some aspect is better the electrical vehicle. The range is also a very important limitation that limit the use of the electrical vehicle mainly to move in the cities, and this is a problem now for road application. The industry is working to increase this range, so the application of the electrical vehicle will be for more matters. The mobility cost is the cost of every kilometer of movement is better in the electrical vehicle. The maintenance is simple, and the environment effect is much better. The decision for moving from the conventional car to the electrical vehicle depends also in the person. There are some people that only with the environment criteria is enough to use an electrical car, but in general, to increase the number of people that take the decision to buy an electrical car, most of these drawbacks must be to improve it. In this point is what the question is what the metrology can do to improve this, and I pointed out two main aspects. One is the legal metrology, and the other one is the scientific metrology. In the legal metrology, we have to support regulation and standardization. There is an important issue in the energy metering and billing, and also in the performance certification, not only of the electrical vehicle, but also of the charge station. My previous speaker talking about of this matter of the certification of the charging station, that is a very important issue that at then we are working behind a couple of years. We have already prepared a first draft of this one, We are also in collaboration with other European institutes working in a common regulation in some way that this can be considered in the future as a European harmonized standard. In the side of the scientific metrology, we can improve the measurement with really a very important tool to improve the efficiency of the energy transfer and use on the different components. The main research points that I would like to talk is the energy transfer to and from the electrical vehicles, energy storage that are in the batteries, and the use of the energy in the powertrain. In relation with the charging, we have received a talk previously, and I have talked about the regulation that we are working on. There are many ways of charging the electrical vehicles. Could be AC or DC. It could be inductive charging, that it is fundamental for what is called the dynamic charging of the vehicle when it is in movement. A very important issue, as I told before, is the charging power. There is also smart charging because in this way the vehicle can be charged in the best moment according to the grid occupation. And also we can consider that the point that the sun energy can be returned to the grid, and also this energy can be used for other applications. As I say, in legal metrology, in reference with the charging, we are working in this regulation. In scientific metrology, we are working to support improvement of the energy transfer from the grid to the electrical vehicle. At this point, we are dealing with a proposal for a research project covering all the steps in the electro-mobility, and one of the steps will be exactly this one, is the transfer of energy from the grid to the electrical vehicle. In relation with the batteries is a big issue. This was told by our president and for many speakers. There is a lot of investment in batteries because I think from my point of view, is the main limitation not only for the electrical vehicles, for in general for the use of the electricity, because this limit the storage capacity. I have pointed here some of the properties that I consider more important. One is the energy density. That's very important for the electrical vehicle, the performance, the capacity, the lifetime. The second life is also an important issue because when the batteries reach the limit condition to be used in the electrical vehicle, can be used in other application. In this sense, in the case of the batteries, in legal metrology, one of the main applications will be the performance verification, and in scientific metrology will be the metrology will help in the research to improve the properties. And also there are one important points, that is we are working in new methods for rapid and accurate measurements of states of charge, the state of health, and a state of safety, for two reasons: to be incorporated in the battery management of the vehicle, and also in the fabrication process to optimize the combination of the elements of the batteries. And finally, the third point is the powertrain. There is a lot of energy transfer from the battery to the engine and to the wheels. We have to use converters for changing the way of this energy, and there are also some energy that comes back to the battery using, for example, the braking times of the engine. In the side of the scientific metrology, I take out these pictures from a paper. I am not going to get in details of all this part, but this can give you an idea of how many change of kind of energy and how many transformation can be inside the electrical vehicle to optimize to use the energy. So optimize all these steps will be important to increase the efficiency of the in the use of this energy. In the legal metrology, I have quoted here what I have been reading in the newspaper, in the advertisements of a lot of properties of the electrical vehicles. These properties of these characteristics will be the deciding point for the consumer to buy one car or the other. But these characteristics must be verified and must be verified with procedures that are traceable to the international system of units. And so methods for the verification of these properties has to be designed and tested. And it's one of the things that the Metrology Institute can do. I have been in these topics, I have been mainly talking about the electrical vehicles, but the use of the electrical energy will be covering many ways of mobility, ships, trains, and also aircrafts. I have to find this in the website. Is from a Germany company that they are dealing with the fabrication of a small jet that comes, takes off and land vertically, and this will be a good solution for this short displacement, about 300 kilometers, and also for in the busy cities from going to the airport, to the city center. The main point is that everything could be digital. The ticket buying and reservation and all these things. So the cost will be very low. And the idea is that the cost will be much lower than a conventional high-speed rail link between the centers. And to end with the conclusion, as I have said in my last slide, electromobility covers many things: electrical vehicles, trains, ships, aircrafts. In the aircrafts, there is also some people working in the possibility to use the electrical energy for commercial aircrafts. Also, in addition to the mobility, to electromobility, the conversion of the electrical energy and use will be covering most of the application, industry, heating system, etc. But research is necessary to get this transformation, and I think that metrology is fundamental to support this research. Thanks for your attention. I'm sorry for the problem I have at the beginning.
Okay, thank you very much, Javier, for your presentation. It was very interesting. And all presentations are done. So first of all, I would like to thank all the speakers for their interesting presentations. I'm aware that this has been a very long event. However, I would kindly ask you to remain connected for a few more minutes and answer some of the questions the attendants have raised during the webinar. First of all, I would like to apologize for not being able to answer all the questions you have raised tonight. However, my colleague Peña has selected the most representative one. I would like to start asking a question to Gustav. The new research and development metrology look for the establishment of networks and partnerships. Can participate non-European countries on those networks?
Can you please repeat that question? If it's non-European.
Yeah, the question is, the new research and development metrology look for the establishment of networks and partnerships.
Yeah.
Can participate non-European countries on those networks? And also, they ask about the small and medium-sized enterprises.
Is the question in Spanish? Because I'm not sure if I understand the question.
Okay, I'm going to try to tell you in Spanish. The Spanish question is, just give me a sec. The Spanish question is, el nuevo programa de I+D en Metrología busca la creación de partenariados redes en Europa. ¿Pueden participar otros países no europeos en esas redes? ¿Pueden también participar empresas pequeñas y medianas?
Okay, I'm going to answer it in English first, and then I can just take a summary also in Spanish. The non-European countries can participate in the same way as they can participate in Horizon Europe. That means that if in the future your country or that country is associated to Horizon Europe, then they could participate in on that aspect. If you're not, there are some other type of rules for participation. Usually you're not funded directly. You can still participate as a non-funded partner. When it comes to small and medium-sized enterprises, yes, absolutely. That's one of our target, let's say, type of entities that we would like to have participated, and we do have a target in the future, in the future partnership as well. To what extent we would like to have industry in there, but absolutely in all calls for proposals, the participation of industry is encouraged. Entonces, solo para decir también en español que sí, depende del país y si en el futuro una asociación con Horizonte Europa también se produce, pero de todas formas, de todos modos, se puede participar, pero a lo mejor no con dinero de la Unión Europea, pero también se podría participar en esos programas. También por pymes, esas empresas también es algo que queremos que participen y también es un objetivo para todos los programas que tenemos. Gracias.
Thank you very much. Then I have another question for Thomas. Thomas, when do you expect to have an harmonized digital certificate?
Yes, great. That's a question. When can we have it and when can we use it? There are some timelines we have to keep in mind. One is that the SmartCom project, where we are collecting and defining the fundamental requirements, will last until mid of this year. And the second is that we need, for a harmonized, worldwide harmonized approach, standards, and standardization means years. Therefore, I would say a really harmonized, worldwide accepted version will take maybe some years. Nevertheless, we have on the start XML-based examples. We have an approach with PDF-A calibration certificates. You can implement it with the risk that you may change it in 2 or 3 years when we have some pre-normative standards available.
Okay, thank you. Thank you very much for your answer. Now I would like to ask to Nieves, Dr. Medina, how does Centro Español de Metrología plan to achieve digitalization? Will it be through internal or external means?
That's a very interesting question. Of course, we will try to use as many internal means as possible. We are very lucky because we have the strong support of our ministry, so that is really nice, it's really good. We also have a very nice IT department at CM that it's small, but it's really involved in digitalization. On the other hand, all the staff of the CM is really involved in digitalization somehow. Inside our plan, we have also defined that there are some needs of training, and at the moment we have already launched a survey in order to know these needs, and we have already started planning the training for the staff. So the idea is to have as many internal participation in the digitalization plan as possible. Of course, we are aware that there will be some things that unluckily we will not be able to do by ourselves, such as some automatization of some equipment, or that could be difficult or something like that, or there will be also some tools that will have to be developed outside, but as much as possible we are doing things inside the institute. For instance, but not only digitalization is always related to IT and automatization. We have already started performing activities that are done by that are really related to digitalization, that have been done already and have been pushed a little bit by the pandemic, such as the online audits, for instance. That is something very challenging and it has been something new. And we have found the advantages and the disadvantages, but we are doing with it, and we are really pushing for that. So have already established the plan. It has to be fulfilled in 3 years, and it's the moment, and we have the people, and we have to do it. So let's hope we finish it by 2024.
Thank you very much, Nieves. Now I would like to ask Unai. It's quite a complicated question, so I'm going to try to translate in English, and then I'm going to ask it in Spanish, because I'm not sure if I translate it properly. The question would be, how can we guarantee traceability in the measures applied in industrial application and virtual twins? In Spanish, ¿cómo se garantiza la trazabilidad de las medidas aplicadas en las aplicaciones industriales y en los gemelos virtuales? Thank you.
Wow, yeah, quite difficult question, but I will say that we will try to make traceable these measurements through the instruments we are employing. I mean, I have shown some examples where we are using mainly laser technology, yeah, and with instruments like laser tracker or laser tracers, and we do know that these instruments are already traceable because they have a calibration, right? So this is how we are trying to make them traceable. But there are different possibilities. For example, when we perform a traceable coordinate measurement on machine tools, we can also employ a different kind of standard. In this case, for example, for medium-sized machine tools, we are using physical standards, yeah? Standards that have been previously measured on CMMs, so we already know which are the dimensions, and we introduce it into machine tools, and we try to measure them. So I will say that we need a standard, physical kind of standard, a laser standard, and try to make measurements traceable this way, right?
Okay, thank you very much, Jose. Now I would like to address a question to Javier Díaz. Do you consider the electrical car would be able to overcome the use of combustion-based cars without forbidding the use of combustion cars? En Spanish, ¿consideras que el coche eléctrico será capaz de sustituir el uso de los coches basados en combustión sin que estos sean prohibidos? Thank you.
Thank you very much for the question. Yes, I am completely sure that it will not necessary to apply a law for the people to decide to the electrical car, because I think there are some problems, but the technology is coming very quick, and I think we are going to solve everything. It's just to have the objective, and I think every day you can see more electrical cars in the street, and in the medium there are many advertising about this. So I think in some years most of the car will be electrical.
Okay, thank you very much, Javier. And finally, I would like to ask a question to Carlos Juste. Which do you think are the biggest resistance for the development of Industry 4.0 and linked to metrology? Carlos, you have your voice is off. Your microphone off.
Yeah, now, sorry again. Probably the companies, the chiefs of the companies, that would be one. Some of them have not the technological culture to accept changes. That's definitely one of them. But as you know, the future always come too late. So probably we need also some efforts from the public administrations. But once again, we need the owners and the decision makers of the companies to understand how important this is to happen, because we cannot stop this. We need to run this new industry as fast as possible for many reasons, but basically for environmental reasons, because we are too dependent of fossil fuels, as some of the opponents today have said, but also for economic reasons. Thank you for your question. I wasn't expecting a question. Thanks a lot.
Okay, thanks, Carlos. Well, I think that was all. Thank you very much for attending this event, especially to the experts that have presented tonight. It has been really interesting, and I hope you have all enjoyed it. Goodbye, and we'll see you in our next event. Good night.
Thank you.